Stop. Did that work? Oh boy, there we go. Is that me? That's me. Okay. So then the last thing we need to do is talk about how to convert from one form to the other. So quadratic functions most commonly are written in standard form. And so just to make sure you're okay with the algebra for that, we're going to go through those algebraic steps. It's definitely not the most important thing on the planet that we become algebra experts, you know, become like pencil paper experts, because, you know, there's computers for that. But at the same time, you need to understand how it works. So I'm going to start with the factored form, which was, I'm just going to put y equals, for the sake of my whiteboard, 1.5 x minus 1, and then x plus 3. Okay, so if you had to figure out what this was in standard form, you just have to distribute it all out. That's it, just distribute. But when you distribute, just be careful. You only take it 2 things at a time. You can't do all 3 at once. That doesn't work. You'll confuse yourself and you'll mess it up. 2 at a time. I personally like to distribute these first. It really doesn't matter. You could distribute the 1.5 in if you really want to. I'm just a creature of habit. I like to distribute my parentheses first. So if I distribute my parentheses first, I have x times x, x times 3, minus 1 times x, and minus 1 times 3. If I combine like terms real quick, that simplifies to x squared plus 2x minus 3. So that's distributing the parentheses, but then don't forget the 1.5 is still there. So you just run the 1.5 all the way through using distributive property. So you end up with 1.5 x squared. 1.5 times 2 is 3. And 1.5 times minus 3 is minus 4.5. So there you go. So that's how you convert factored form into standard form. Factored, can you see that? Yes, into standard. Now, the benefit, of course, of standard is now I know my vertical intercept is negative 4.5. Quite frankly, you could have just plugged in 0, right? By definition, the vertical intercept, you just plug in 0. So you don't have to distribute it just to get minus 4.5. I mean, you could, but you don't have to. You can just put a 0 right there, put a 0 right there, grab a calculator, punch it all in, you'll get negative 4.5. So again, the algebra is a nice tool to have in your pocket in case you're wanting to convert between forms, or if the directions ask for it written in a specific way. You just have to be able to know how to distribute if and when the time comes. As far as the vertex, because again, factored form, you get the x-intercepts out of that, which is lovely. Now you have the y-intercept as well. But the vertex, you're like, I still don't have the vertex. So obviously we have Desmos, okay? So you can just put it in Desmos, touch the dang vertex, and you'll be fine. But if you want a little fun fact, since parabolas are symmetric, whoop, the vertex is always in the dead center of whatever the x-intercepts were. So if you think about it, if this x-intercept, oh man, that's not drawn to scale. Hang on, let me fix that. Let's put it more like here. Okay. So if these x-intercepts were at positive 1 and negative 3, then wherever the midpoint is of positive 1 and negative 3, that will be the location of your vertex. It's always in the middle. And if you're wanting to figure out, well, how do you find the middle? You just average them. So negative 3 plus 1 divided by 2, just to the average, add them up, divide by 2. Negative 3 plus 1 is negative 2, divided by 2 is negative 1. So if you recall on your Desmos, the vertex was absolutely at -1. Yep, it's at -1 comma -6. So if you know where your x-intercepts are, you could get your vertex by just finding the middle of those two numbers. And then once you know the vertex is at -1, you'd have to plug it back in. Yeah, like don't get me wrong, -1 isn't the entire answer. You still take -1, plug it back in, and if you crunch all that out, you'll get -6. Okay, so maybe try that on your own. Make sure you can get -6 if you had to. So that's how factored form can essentially lead into all of the things that you might need. You could distribute it out, you got the vertical intercept, you could plug in 0, you could find the midpoint. Factored form is actually pretty cool. In the same token though, it's not that common. We don't use factored form that often. So either way, that's factored form. Now, what if you wanted to go from vertex form? So where's my eraser? I lost my eraser. Well, that's strange. I really did lose my eraser. I guess we'll just use this. It's a coaster. We're going to use a coaster. All right. Hey, it works. Oh boy. Welcome to online learning, friends. Okay. So the factored form, let me just remember what that one was. It was the 1.5 parentheses x plus 1 quantity squared minus 6. Okay, so again, why do we like vertex form? Because it's transformations. +1 means to the left 1, -6 means down 6. And now I know that my vertex is at -1 comma -6. Yay. That's why we like vertex form. But what if you wanted to, once again, what if you wanted to distribute it out and be in standard form? So on this one, the main thing you need to know is that when you distribute this, you have to do the parenthesis squared first. Order of operations, parentheses squared. So before you do anything else, you have to figure out what x plus 1 times itself is. So distribute that out, x squared plus 1x plus another x plus 1. So distribution, combine like terms, so you got two x's in the middle. And now you can bring everything else down. So all of that still has to get multiplied by 1.5. And then eventually you also have to take away 6. We'll do that at the end. But first, let's distribute the 1.5. So 1.5 times x squared is simply 1.5x squared. 1.5 times 2 is 3x. 1.5 times 1 is 1.5, but then now drop down the takeaway 6. So the final answer is y equals 1.5x squared plus 3x. 1.5 take away 6 is minus 4.5. And you are right back into your standard ABC form. You'd have your vertical intercept at this point. Now you know the vertical intercept is at -4.5. But again, don't get me wrong, just plug in 0. I don't care what chapter we're in. If you want the vertical intercept, plug in 0. Do the math. You'll get -4.5. You will, I promise. Or you could distribute it all out and change the way it looks, and that is beneficial sometimes, but nonetheless, just want you to see your options. Now, the bummer is that none of this tells you the x-intercepts. Nope, not convenient at all. I got no tricks, nothing up my sleeve for you. The only way to find your horizontal intercept from something like this is using the quadratic formula. -b plus or minus the square root of b squared minus 40c all over 2a. And guess what? We're not doing that in this class. So don't worry about that. You got Desmos. If you really need to know the horizontal intercepts, put it in Desmos. touch the dang x-intercepts and move on. Okay? Okay, so you've got 3 different forms. Obviously, they each have their advantage. We like some better than others, and I think that's fine. If you had to algebraically convert between one and the other, you could, I hope you could. And yeah, you've always got your technology though to help, so don't feel too stressed about that. Just familiarize yourself with it and go do some practice problems before you do any of the mandatory assignments, okay? If you have questions, come to my office hours. All right, guys, I'm going to stop this. Thank you for your time. Hope you guys are well.